Good afternoon to one and all. This is Maria Pushpam, and for today's class, we are going to see coulometric method or coulometry. If you see this method, there are two different types of coulometry. One is constant current coulometry, another one is constant potential coulometry. It's said to be potentiostatic coulometry. Okay, so coming to this coulometry, same as that of the previous one. So if you take this electroanalytical technique, the last class we have seen electrogravimetry, its principle, instrumentation as well as application, and two types of electrogravimetric methods we have seen. One is said to be constant current electrogravimetry, another one is constant potential electrogravimetric method. And now for today's class we are going to say what is said to be coulometry and the types of coulometry. Okay, so I'll start with coulometry. So what I mean by coulometry is it's an electroanalytical technique in which the amount of substance deposited at the electrode is determined by measuring the quantity of electricity passed through the electrolyte solution. I'll repeat. So what I mean by coulometry is nothing but the electroanalytical technique. இதுவும் என்னதான் electroanalytical technique. First technique வந்து electrogravimetry, and this technique we call it as coulometry. There we have measured the amount of substance. Gravimetrically we have determined, and here we are going to measure the current supplied. What is the amount of current supplied for deposition of the metal? That's the principle behind. So I'll say the thing. What is coulometry? Coulometry is an electroanalytical technique in which the amount of substance deposited at the electrode is determined by measuring the quantity of electricity passed through the electrolyte solution. Since the quantity of electricity is measured in coulomb, the method is called as coulometry. The method is called as coulometry. And now the principle. Coulometry is based on Faraday's first law, same as the previous method. What you have to do here is the amount of substance deposited at the electrode during electrolysis is directly proportional to the quantity of electricity passed through the solution. It's directly proportional to the quantity of electricity passed through the solution, and we are going to measure only the quantity of electricity. From that we can find what is the amount of substance deposited over there. Is it okay? So this is a method here. So I'll repeat the principle. The principle is based on Faraday's first law, and you know the law previously I have said you. The amount of substance deposited at the electrode during electrolysis is directly proportional to the quantity of electricity passed through the solution. Okay, and is given by the formula W is proportional to Q. W is proportional to Q, and W is equal to Z into Q, where Z is said to be the proportionality constant, which is otherwise called as electrochemical equivalence. And electrochemical equivalence is nothing but M divided by NF, where M is the molar mass of the substance, N is the valency of the element deposited, and F is the Faraday's constant, which is nothing but 96,500 coulomb per equivalent. So Z is the value, and now W becomes W is equal to MQ divided by NF. Is it okay? I'll repeat this Faraday's first law based on the principle of, this is a principle behind coulometry. So principle is nothing but it is based on purely on Faraday's first law. The law states that the amount of substance deposited at the electrode during electrolysis is directly proportional to the quantity of electricity passed through the solution. In this method you are going to just measure the quantity of electricity passed. There's a method behind, and it's given by the formula W is proportional to Q, and W is equal to ZQ, where Z is said to be a proportionality constant, is otherwise called as electrochemical equivalence, which is given by the formula Z is equal to M divided by NF, where M is the molar mass of the substance, and N is the valency of the element deposited, and F is the Faraday's constant. And now the formula becomes W is equal to MQ divided by NF. Is it okay? It's clear now. So if we take this coulometry, Next thing what we are going to see is types of coulometry. Same as electrogravimetry, here also we are going to do two types of coulometry. In one type we are keeping current constant, the second type we are keeping potential constant. Okay, I'll say the method. So coming to the types of coulometry, there are two types of coulometry. One is called as constant current coulometry, or it's called as amperostatic coulometry. Amperostatic coulometry is nothing but ampero means nothing but current. Static means constant, standard. Static na அப்படி நிற்கிறது constant சரியாமா. So constant current coulometry, it's otherwise called as amperostatic coulometry. Second method is called as controlled potential coulometry, or it's otherwise called as potentiostatic coulometry. Potentiostatic na என்னன்னா potential வந்து கான்ஸ்டண்டாக இருக்குது, potentiostatic coulometry. So first we can see what is said to be constant current coulometry. Constant current coulometry உங்களுக்கு மெத்தட் சொல்லாமலே தெரியும். இந்த மெத்தட் நம்ம எப்படி பண்ணுவோம்னா, நம்ம ப்ரீவியஸில் எலக்ட்ரோகிராவிமெட்ரிக் மெத்தட் பார்த்தது மாதிரியே கரண்ட்டை வந்து கான்ஸ்டண்ட்டாக வச்சுட்டு பண்ணுவோம் சரியா. ஸோ எலக்ட்ரோலிசிஸ் இஸ் கேரிட் அவுட் பை பாசிங் கான்ஸ்டன்ட் கரண்ட் த்ரூ தி எலக்ட்ரோலைட். இந்த மெத்தடில் என்ன பண்ணுவோம், எலக்ட்ரோலிசிஸ் இஸ் கேரிட் அவுட் பை பாசிங் constant current through the electrolytical solution, and the quantity of electricity required for the reduction of the substance at the working electrode is calculated using the relationship Q is equal to I into T, where Q is the quantity of electricity passed, I is current strength, and T is the time in minute. So these are things you have to bear in mind. I'll repeat. So constant current coulometry or amperostatic coulometry is nothing but, in this method electrolysis is carried out at constant current through the electrolytical solution. You have to pass constant current through the electrolytical solution, and the quantity of electricity required for the reduction of the substance at the working electrode is calculated using the formula Q is equal to IT, and Q is nothing but quantity of electricity required, and I is current strength, and T is the time in minutes. Is it okay? So now we can go to the apparatus setup. Is it okay? So how to construct the apparatus? What are the components there is? An amperostat. Amperostat is nothing but a source of supplying constant current is called as amperostat. Apparatus is, a kit will be there. It will produce current of constant speed. Okay. So source of constant current. Second one, electrolytical cell. It consists of a working electrode as well as a counter electrode. And this counter electrode is enclosed in a glass tube to prevent the side reactions at the working electrode. And third component is current measuring divisor. It's nothing but the device is a milliammeter, is used to measure the current strength. And fourth one is a time measuring device. It's a digital timer, is used to measure the electrolysis time. எவ்வளோ நேரம் வந்து electrolysis வந்து நடக்குதுங்கிறத மெஷர் பண்ணுறதுக்கு we have a device called as time measuring device. Another fifth one is nothing but a switch. It is used to stop the electrolysis current as well as a digital timer. Digital timerையும் எலக்ட்ரோலிசிஸ்க்கு தேவையான கரண்ட் கொடுக்குற அந்த அப்பரேட்டஸை ஆப்ரேட் பண்ண ஒரு சுவிட்ச் வந்து வச்சுருப்போம். ஸோ 5 components are there. An amperostat, it's a source of supplying constant current. Electrolytical cell, அதில் வந்து ஒரு ஒர்க்கிங் எலக்ட்ரோடும் ஒரு கவுண்டர் எலக்ட்ரோடும் இருக்கும். அந்த கவுண்டர் எலக்ட்ரோடு எப்படி இருக்கும்னா ஒரு கிளாஸ் டியூபுக்குள்ளே இருக்கும். எதுக்கு அப்படி வச்சுருக்கோம்னா, இட்ஸ் டு ப்ரிவெண்ட் த ரியாக்ஷன் அட் தி ஒர்க்கிங் எலக்ட்ரோட், சைடு ரியாக்ஷன் அட் தி ஒர்க்கிங் எலக்ட்ரோட டைரக்ட் கான்டாக்ட் வராமல் இருக்கிறதுக்கு வேண்டி அப்படி தனியாக வச்சுருப்போம். தேர்ட் காம்பனண்ட் இஸ் தி கரண்ட் மெஷரிங் டிவைஸ், அண்ட் ஃபோர்த் ஒன் இஸ் டைம் மெஷரிங் device. Fifth one is a switch to control this current measuring device as well as the time measuring device. So this is a whole setup required for your constant current coulometric method, or it is otherwise called as amperostatic coulometric method. For this method you need 5 different components: amperostat, electrolytical cell, current measuring device, time measuring device, as well as a switch. Okay. And coming to the application of this constant current coulometric method, it is used in coulometric titration. We'll see this elaborate in the next class. Okay. While I'm taking the next class, I'll elaborate you with this coulometric titration. It's clear now. So first method I have taught for today's class is nothing but constant current coulometric method, or is otherwise called as amperostatic method. And second type of this coulometry is called as controlled potential coulometry. Controlled potential coulometry, it's constant potential coulometry. It's otherwise called as potentiostatic coulometry. Potentiostatic coulometry. And if you take this, electrolysis is carried out by controlling the potential of the working electrode at a constant level. So இதில் என்ன பண்ணுறோன்னா, நம்ம ஒர்க்கிங் எலக்ட்ரோடோட பொட்டன்ஷியலை வந்து கான்ஸ்டண்ட்டாக வந்து மெயின்டைன் பண்ணி தான் இந்த எலக்ட்ராலிசிஸ் ப்ராசஸ் நம்ம வந்து பண்ணுவோம். எல்லாமே எலக்ட்ராலிசிஸ் தான், சரியா? ப்ரீவியஸ் மெத்தடில் பார்த்தோன்னா எலக்ட்ராலிசிஸ் வந்து கான்ஸ்டன்ட் கரண்ட் வச்சு பண்ணணும். இந்த மெத்தடில் பார்த்தீங்கன்னா எலக்ட்ராலிசிஸ் இஸ் கேரிட் அவுட் பை கண்ட்ரோலிங் த பொட்டன்ஷியல் ஆஃப் த ஒர்க்கிங் எலக்ட்ரோட் அட் அ கான்ஸ்டன்ட் லெவல். ஸோ தட் என்ன நடக்கும்னா, உனக்கு வந்து ஆக்சிடேஷன் ரிடக்ஷன் வந்து நடக்கும் ஆஃப் தி அனலைட் வில் அக்கர். ஒன்லி ஆக்சிடேஷன் நடக்கும் அல்லது ரிடக்ஷன், அனலைட்டோட ஆக்சிடேஷன் நடக்கும் அல்லது ரிடக்ஷன் வந்து நடக்கும். நடக்கும்போது த கரண்ட் இஸ் இனிஷியலி ஹை. ஏன்னா இதில் வந்து கரண்ட் வந்து வேரி ஆகும். த கரண்ட் வில் பி இனிஷியலி ஹை இன் திஸ் ப்ராசஸ், தென் இட் டிக்ரீசஸ் அண்ட் அப்ரோச்சஸ் ஜீரோ அட் த கம்ப்ளீஷன் ஆஃப் த ரியாக்ஷன். ஸோ முதல்ல கரண்ட் பார்த்திங்கன்னா ரொம்ப ஹையாக இருக்கும். நமக்கு ரியாக்ஷன் நடக்க குறைஞ்சிட்டே இருக்கும். ரியாக்ஷன் முடிஞ்சிட்டுனா நமக்கு என்ன இண்டிகேஷன்? கரண்ட் வில் பிகம் ஜீரோ. த குவான்டிட்டி ஆஃப் எலக்ட்ரிசிட்டி மெஷர்ட் ஃப்ரம் த ரீடிங் ஆஃப் த coulometer is in series with the cell, and the current versus time graph is plotted or it's constructed. I'll repeat the method once again. So in this method, electrolysis is carried out by controlling the potential of the working electrode at constant level. So what happens here is, so that the quantitative oxidation or reduction of the analyte takes place, and the current is initially very high but decreases and approaches zero at the completion of the reaction, and the quantity of electricity is measured from the reading of the coulometer in series with the cell. நமக்கு இந்த கனெக்ஷனில் பார்த்தீங்கன்னா அடுத்த கிளாஸில் உனக்கு இந்த அப்பாரட்டஸ் செட்டப் சொல்லி கொடுப்பேன். அப்போ வந்து உனக்கு கிளியராக புரியும் எதுக்கு அப்புறம் எது எப்படி கனெக்ட் ஆகிருக்கு. அப்போ இதில் வந்து நீ கரண்ட்டை வந்து மெஷர் பண்ணுறதுக்கு coulometerல தனியாக ஒரு செல் வந்து கனெக்ட் பண்ணியிருப்போம். Okay, so now we have to plot a graph between current versus time, and from the graph you can find what is the amount of current required here. Is it okay? So I'll show you the plot here. You are able to understand the method. So electrolysis வந்து constant potential பண்ணுறோம். Oxidation அல்லது reduction அனலைட்டில் நடக்கும்போது, so as the reaction takes place, initially the current will be very high. As time goes on, what happens here is the current will be reducing, and when the completion of the reaction takes place, the current will become zero, and this current measurement can be easily done by a connection in the coulometer. Connection will be there, and the current versus time is a graph is plotted. You get a graph of this mode. Okay, and your graph is nothing but if you take the graph is between you have a curve. The curve, if you see the initial one for 0 time, the current is found to be very very high. அப்புறம் பார்த்தீங்கன்னா குறைஞ்சு it is decreasing, it is coming to 0 when the time becomes maximum time பார்க்கும்போது completion of reaction பார்க்கும்போது current becomes 0. முதல்ல ஹையில் இருக்கு, நான் சொன்ன மாதிரி ரியாக்ஷன் தொடங்கும், அப்புறம் குறைஞ்சு ஜீரோக்கு வந்துடும், சரியா? the area under the graph will give you the quantity of electricity passed. இந்த ரியாக்ஷன் நடக்கிறதுக்கு எவ்வளவு கரண்ட் தேவை, ஏன்னா இதுவுமே ஃபர்ஸ்ட் லாவை பேஸ் பண்ணி தான் நடக்குது. ஓகே பிரின்சிபல். ஸோ எவ்வளவு தேவைங்கிறது நம்ம எப்படி கண்டுபிடிப்போம்னா, the area below the curve will give you the quantity of electricity passed during the process. அப்போ Q is equal to integral of 0 to t I into dt. Q is equal to integral of 0 to t I dt. Your answer is nothing but Q is equal to I into t. I into t. That's nothing but quantity of current supplied will be equal to current strength into time in minutes. Into time in minutes. Is it okay? And you can substitute the value of this in the formula given below, which is nothing but amount of substance deposited is calculated by the equation Q is equal to, Q is nothing but quantity of current supplied will be equal to N into W into F divided by M. You can calculate from the previous formula, you can calculate Q. So you can find Q is equal to N into W into F divided by M, where N is the valency of the element, F is Faraday, that's 96500 coulomb, and W is the amount of substance deposited, and Q is the quantity of electricity passed through the solution, and M is the molar mass. So from this you can find the amount of substance deposited in the electrode. Is it okay? Is it clear? So I'll repeat the second method once again. So I think you are clear with the first method. Second method, what you have to do here is, so what are things you have to do? Electrolysis process at constant potential. Then as oxidation or reduction takes place, what happens there is the current will be initially high and decreases. Then it approaches zero at the completion of the reaction, and the quantity of current is measured using a additional cell in the coulometer. And you have to plot a graph between current and time. As you plot the graph, you get the graph of this model, and the area below the curve will give you the quantity of electricity passed during the process, and using this you can find what is the amount of substance deposited on the electrode. So amount of substance deposited is calculated by the equation Q is equal to N into W into F divided by M. We know the value of Q, we know the value of N, and we know the value of F as well as we know the value of M. M is molar mass, F is Faraday, N is valency, Q is quantity of current supplied. From that we can find what is the amount of substance deposited on the electrode can be calculated. So this method we call it as controlled potential coulometry. It's otherwise called as potentiostatic coulometry. Is it okay? So we can have a short recap of the thing what we have seen for today's class. I'll go little by little so you can understand and study slow and steady. Is it okay? So things what we have seen for today's class is only a simple thing we have seen. What is coulometry I have taught you, and the principle behind coulometry is nothing but Faraday's first law. And there are two types of coulometry. One is constant current coulometry, or it's otherwise called as amperostatic coulometry. And second one we call it as controlled potential coulometry. It's otherwise called as potentiostatic coulometry. Is it okay? I think you are able to understand the thing what I have taught for today's class. Keep on studying. Thank you for listening.